CPU. Depends on what you want to do.
Right, and so there have been, for example, I think there was a smartphone in Palo Alto where they connected to watch. I mean, to tactile.
Yeah, the latest tactile paper uses COTSon.
So, for example, there are other ways in which you can hook these up to other models, power models and stuff like that. Wow. And in many cases, if you just want an open loop interaction for like power, you just can get a trace. I mean, like write one tracer molecules that Danielle was talking about, and don't even need to get it too much into the simulator itself. Now, the advantage of doing this is that unlike using other simulator where you get alpha instructions, which is kind of dinosaurs these days, you can run, you can boot Windows and get anything up.
We are working with Spanish University, and one of the first things they are network people, so they're not microarchitecture people. Most network people, they just get, they have certain kind of applications like matrix multiply and other applications, and they basically run those applications and they get traces for networks, and they don't really have anything else. So when you talk to them, have you used traces for an AND, or have you used traces for a real application? They don't really know how to get real traces from a real application, so this is perfect for them. In fact, they used it and they enhanced it and they put lots of lots of network models for us to use, basically because for them, they set up a cluster of 100 nodes and they put something in the output of when we spill out the packet, and they just measure that, and for that, those kind of traces was perfect for the synthetic studies, and instead of using synthetic traces or something.
And there are also applications that that are extremely useful to use this kind of environment. Is, for example, if you want to study commercial application, you can go to Oracle, download their Windows installer or their Linux installers, set it up here, and run it, and it actually works without a problem. It takes a little more configuration effort. And then you can get an Oracle trace for memory accesses for multi-core, whatever, which is extremely valuable, which you can't get any other place. Because you cannot instrument the bus in the machine. And then with that, you can do a lot of research, even without getting inside COTSon itself. If you don't worry about having feedback and things like that, we just have to say, well, when I get a trace of Oracle or SAP memory access, you can just do that. Or if you want to get into more of the working of COTSon itself, then you can actually build a module to provide feedback live, so that Oracle will change its scheduling policies based on how long it really takes, etc., etc. So you can decide how dirty you want to get. If you whether you can get really committed, or you can sort of go halfway through and bridge this up to other tools that you might be more familiar with. But we don't have any personal point. Wherever people want to do this lab.
You're in the research business, so if you use it and you publish it, you say use it.
Oh, and the most important thing is none of us is in the simulator business. So we actually don't want to believe there's value in people using these simulators to study architectures that both AMD and HP care about, not to actually buy the simulator. So if you show that by running your own whatever architecture improvement, you can show that you can run something better on a combination of AMD processors in this particular case and other things that we care about. I think that's a success for us.
I have a question. Excuse me for the curious question, just for curiosity. COTSon was tested also with Mac operating system, for example, Leopard.
I'm sorry, what operating system?
If this framework was tested also, because it was tested with Linux, with Windows, I saw, but with Mac operating systems.
No. Teresa, have you ever tried booting an Apple operating system?
For example, Leopard.
We have not tried booting an Apple operating system.
I suspect there are some kind of illegal.
I think the main problem would be that, as far as I know, Leopard and Mac only runs well. It can run something else, but it only runs well on a Macintosh, and a Macintosh has its own BIOS, and that's one of the tricky parts. So Signal only provides BIOSes for their systems, and other companies provide BIOS for their own systems. For example, HP builds their own BIOSes for the blades and all that use AMD processors. We build our own BIOSes.
Yeah, we
But I don't
definitely
think that-
don't have a BIOS for an Apple.
Yeah, I don't
I'm
think
like you.
Apple will build their own BIOS, right?
But I'm sure that you could actually,
You
chances
could go
are
to an
that
Apple
it
and you could take the BIOS out, you could get the
Yeah.
from.
You can model it and take the BIOS off, put it in
So
there.
that would be,
That'd be
no problem.
interesting.
I don't know, maybe, sometimes with simulators, you never know, you try things out and they work. You never know.
Same problem of compiling a program from
But
Right,
you
so
can model
they
it
ask
with an
different
AMD processor, not
They
a
run-
other
they run
processor.
they'll run okay.
I guess the Apple